Thanks for joining us at Pack Expo Las Vegas 2013. Here we've got a demo of R&W safety couplings, proving that the quick reaction time can be a better safeguard against overload than electronic current limitation. Our demo starts out with a current-limited servo motor. It's got a rated torque of 8 Newton meters, held currently to 30%, and a 10-to-1 gearbox. That means our limited maximum output torque is 24 Newton meters. We're now going to simulate a blockage while it runs at 160 RPM to see if our safety coupling is going to disengage. Indeed it does. The disengagement torque setting of this coupling is 60 Newton meters, more than 2 times the limited torque at the output of the gearbox. The reason it disengaged is because if you attempt to stop a rotating mass in 0 time, you will have infinite torque. Here we don't have that, but we have a safety coupling that is responding to torque overload in a way that the servo is not capable. So after our safety coupling disengaged to prevent transmission of torque overload through the driveline, we shut down the motor. We're ready to re-engage after clearing the jam. This is our full disengagement torque limiter. There are some models that will attempt to re-engage on their own. This one, however, is a manual re-engage. It's good for situations where the overload may not be sensed immediately and also for higher speed applications. To re-engage the full disengage model, the hubs need to be lined up into the proper orientation so that the ball bearings are over their detents, and then an axial force applied to the switch plate so that the springs can snap back over center and re-engage the coupling. The demo unit on the machine, once again, was our full disengagement model, which requires a manual reset, either with a fork or a simple pair of flathead screwdrivers. Here is a single position model of the same size. It's essentially the same principle. We have an adjustment nut which adjusts the torque on a spring disc and plate. That's what loads these ball bearings into cone-shaped detents in the output. When the torque limit is exceeded, the balls actually jump out of their detents, and that's pushing the spring plate back away at the same time. So with the single position version, there's a constant spring pressure, so once per revolution, the balls are able to reseat and it automatically re-engages.
For more information, application assistance, or advice on any of R&W's standard or full disengagement safety couplings, visit rw-america.com.